Hello, welcome to a lesson on classifying triangles. Triangles are our most basic polygon having three sides, and there's two basic ways to classify them. One is by looking at their sides to see if they have the same size or same measure side or different measures, or you can look at the angles. Okay, an example of each one of these. Well, let's actually do several examples. So if you were to classify a triangle by looking at its sides, what if a triangle had all different side lengths? So that's looks to be that this side is different than this side is different than this side. We call that scalene, all different sides. You can have a triangle with at least two sides that are equivalent. So notice the phrase at least. If this side is equivalent to this side, we call that an isosceles triangle. And I am hoping I spelled that correctly. And then lastly, you can have a triangle where all of the sides are equal in length. Okay, so then this side is equal to this side is equal to this side. This is called equilateral or equal length. All right. Equilateral triangles, by the way, by definition, are also isosceles. But the best way to talk about them is equilateral. That way people really know what you're talking about. If you're going to classify them by angles, not sure why I'm using the different colors there. If you're going to classify them by angles, if you have three, well, let's just say this. On a triangle, two out of three angles will always be acute. They'll always be less than 90 degrees. And there's a lot of good reasons why. So it's really that third angle that you're going to use. And I say third because, like, what's the third one? Depends on where you start looking to look at that. So you could have a triangle where all of the angles are less than 90 degrees. That wasn't real clear there, but I think you can look at that and say that they're all acute angles. This would be an acute triangle. There's lots of different versions of those. We'll look at some in GeoGebra in a second. If you have one of the angles that's obtuse or larger than 90 degrees, so notice I made a rather obnoxious looking angle there. That angle is large. This would, since it has an obtuse, the third angle is obtuse, we're going to call it an obtuse triangle. The last classification is if you have an angle that is a right angle. And you can only have one because, again, at least two angles must be less than 90 degrees. If you did have a right angle, so I'll mark it here as right, that would be called a right triangle. You can look at any one of these on GeoGebra. Let's just talk about it real briefly. Going over to GeoGebra, if you use your basic polygon tool and you just click 1, 2, 3 points, you have triangle ABC, but you have to go back and click the original vertex A to close it out. So if you were to get the angle measures of those, let's just click on a few of those. And we can see what kind of triangle we could classify this as. Let's move those inside just a little bit. You can see in this case, there's three different angles. Now we didn't, but the thing to really notice is that they're all less than 90 degrees. So this would be an acute triangle. If I were to move one of these, notice that angle B is now larger than 90 degrees. So this is called an obtuse triangle. If you were to try and get that exactly 90 degrees, and I'm going to struggle with this, but if you could somehow get that exactly at 90 degrees, which I'm not getting, of course, then it would be a right triangle. If you want to use GeoGebra to construct a right triangle, then you're really going to have to construct a right angle to start with. So if you, let's just show you that just so you can have an idea. If you were to construct a segment and then draw a perpendicular line, okay, choose the perpendicular tool. You can construct a perpendicular if you do it correctly. Let me do undo right there. Let's try it again. Click perpendicular line. Click A and click the line segment. You can see it puts a perpendicular line. Then you can put a point anywhere on this line. Okay. Then you could actually make this line go away. Say, okay, don't show me that anymore. That way it's not in the way. Then when you click your polygon tool, A, C, B, and back to A, it's fixed as a right angle. In other words, no matter if you move C up or down, or if you move B, it always stays at a right angle. That angle at angle A would be always 90 degrees. So you can do something similar with the sides as well.